The aim of this research is to analyze the effect of production automation on national levels of income inequality. Automation in production marks the convergence of two important factors in social development. The introduction of robots in industry increases the productivity of a national economy, reduces labor costs, and allows the manufacturing of high-tech products. It also, however, arguably widens the gap in the salaries of low-skilled workers and high-skilled workers. This trend is therefore likely to be reflected in an increase in the national level of income inequality. Controversially, however, there are countries which are heavily exposed to industrial automation and yet are characterized by lower levels of income inequality.
The reason behind this paradox is perhaps the variation in the capacity of social systems to adjust to production automation. Arguably, that capacity is determined by the country's institutional structure, formed by the continuous action and interaction on behalf of social actors, driven by their ambition to improve the material conditions of their existence. The introduction of multipurpose industrial robots in production is simultaneously the product of social interaction and a social force which transforms the terrain on which that process occurs. Automation is therefore a representation of the dual relationship between individual action and social structure. Assumedly, the functionality of a national institutional structure is reflected in the sophistication of the products a country exports. Figure 1 illustrates an association between economic complexity and income inequality. In this regression, an index of economic complexity based on the technological intensity and diversity of the products a national economy exports acts as the independent variable, while the dependent variable represents the degree of inequality in national income distributions captured by the Gini coefficient. There is a robust negative association between the two variables. In essence, the complexity of a national economy can be regarded as a proxy of the knowledge and know-how available in the national social system. The reason is that, apart from a higher degree of automation, the manufacture of complex industrial products also tends to require a large degree of tacit knowledge and more distributed knowledge than found with simple products that are mainly based on resource richness or low labor costs. Interestingly, economic complexity is not captured by aggregate measures of human capital, such as the educational attainment of the population. In addition, economic complexity is also an indicator of an economy's level of social capital and the health of its institutions, since the ability of a country to produce sophisticated products also critically depends on the ability of people to form social and professional networks. Arguably, the high degree of social integration can enhance the incentives to unionize and thus compress wage inequality. Furthermore, a more inclusive institutional structure and higher social capital can help individual social actors better realize their role in the national economy and can thus increase the likelihood of cooperative behavior. The methodological challenge of this research is to disentangle the effect of automation on income inequality from the one of the institutional structure of society captured by its economic complexity. The chosen method is quantitative and employs an ecological cross-sectional design. The sample includes only countries which actively participate in the trading of industrial robots, while the estimation of the effect of automation on inequality is done by multiple regression including observable confounders. Figure 2 outlines the two regression models devised for the purpose of exploring the effect of automation on income inequality. The independent variable of interest, exposure to robots, is derived from the total value of imported and exported robots during a period of 10 years for each country. The data required for this analysis is secondary, quantitative data available at UN Comtrade and the World Bank. The project does not rely on random sampling, for the reason that the effect of automation is expected to vary according to the country's stage of economic development and to their position in the interconnected global economy. On one side, in advanced industrial countries, automation is associated with decline of unionization and an increase in income inequality. On another side, in developing countries, automation is associated with an emergence of a middle class and a decline in income inequality. Neglecting the differential impact risks failure at capturing the effects of automation. Given the interconnectedness of the international economic system, the square term of gross national income aims to control for the difference in the effect of industrial automation on income inequality. The first model attempts to capture the association of production automation and income inequality. The second model introduces economic complexity as a control, and thus explores the way in which the former association changes when the influence of social structure is controlled for.
The successful attainment of valid and reliable results will serve to outline the impact of the path-dependent processes dictated by the technical requirements of the automated production line. That result will allow effective policy making as humanity advances to the next technological age.